On July 15th, 2025, Apple did something it had not done in 15 years. It signed a $500 million deal to buy magnets. Not from China, but from a single mine in California. Tim Cook framed it carefully. Rare earth materials are essential for making advanced technology, and this partnership will help strengthen the supply of these vital materials here in the United States. What he did not say in the press release was the reason. 3 months earlier, in April, China had quietly tightened export rules on the exact materials Apple needed. Inside every iPhone and every Samsung, every Google Pixel, every Android phone on Earth, sit roughly 8 different rare earth elements you have probably never heard named. Neodymium, praseodymium, dysprosium, terbium, yttrium, cerium, lanthanum, gadolinium, 8 elements. Most consumers cannot pronounce them. Almost no one can name where they come from. Without them, the phone in your pocket does not work the way you have come to expect. Roughly 60% of them are mined in China. Roughly 90% are refined there. For the heaviest, most critical of them, the elements that make the magnets in your speaker actually generate sound, the figure rises to approximately 99%. Start with the magnets. They are the smallest and the most critical components most consumers have never seen. Every smartphone contains at least 3 of them, often more in higher-end models. 1 in the speaker, 1 in the microphone. 1 in the vibration motor that buzzes when a notification arrives, each one roughly the size of a grain of rice. These are the strongest permanent magnets ever manufactured. Per kilogram, they generate roughly 10 times the magnetic force of the ferrite magnets you find on a refrigerator door, which is why they can fit inside a smartphone speaker only a few millimeters thick and still produce audible sound at any volume the user demands. They are made from neodymium, iron, and boron, plus small amounts of dysprosium and terbium added to keep them stable when the phone gets hot. Without dysprosium, the magnet loses its strength when the phone reaches roughly 80 degrees Celsius, which is the temperature your phone reaches in your pocket on a warm summer day in direct sunlight. China refines approximately 99% of the world's heavy rare earths, not because the elements only exist in Chinese soil, they don't, but because the chemical separation and refining process is technically demanding, environmentally messy, and capital intensive, and no other country has built that capacity at scale. Without it, the speaker on your phone cannot push air, the microphone cannot capture sound, the vibration motor cannot generate force. And these 3 magnets are only the start. 5 different phone components depend on rare earths. What looks like a single small lens on the back of every modern smartphone is actually a stack of 6 to 8 individual glass elements, each one ground to optical precision, each one positioned within microns of its design location. Modern smartphone camera lenses are made from a special type of glass containing lanthanum oxide. It is the same family of optical glass that high-end professional camera manufacturers, Leica, Zeiss, Canon, have used for decades, but adapted to the millimeter scale demands of smartphone optics. Lanthanum gives the glass a high refractive index, which means light bends more sharply as it passes through. It allows the lens to bend light with less thickness. A camera lens stack made from ordinary optical glass would need to be roughly twice as thick to achieve the same focal length and image quality. Phones would have to be measurably thicker to accommodate it. And lanthanum, like the other rare earths, comes overwhelmingly from Chinese supply chains, mined in Inner Mongolia, refined in chemical plants in the same region, then shipped to optical glass manufacturers in Japan, Germany, and South Korea, who supply Apple, Samsung, Google, and the rest of the global smartphone industry. Every photo you have ever taken with a phone passed through it. What looks like a single sheet of glowing color on every smartphone display is actually millions of microscopic individual light sources, each one chemically engineered to emit a specific wavelength. Every red pixel on your screen is generated by a phosphor compound, a specific chemical that when struck by electricity releases light at exactly the wavelength your eyes perceive as red. Yttrium and europium together produce the deep red wavelength your eyes see. Without them, the red shifts toward orange. Color accuracy breaks down. Skin tones look subtly wrong. The display stops being faithful. On a typical smartphone display, that is roughly 3 million red pixels, each one depending on the same phosphor chemistry. Yttrium, like the magnets, is processed almost entirely in China. China refines approximately 85% of global yttrium output, and the glass surface is polished using cerium oxide. Cerium is the highest volume rare earth used in consumer electronics. 8 elements, 5 different phone components, one country supplying nearly all of them. Most of that processing happens in Inner Mongolia, even rare earth ore mined elsewhere. Australia, the United States, Vietnam, Brazil has historically been shipped to China for separation and refining. Mining is the easy part of the rare earth chain. Refining is the hard part. Long chains of acid baths and electrochemical separation cells, enormous volumes of toxic waste, decades of accumulated expertise. And refining is where China holds the grip. Mountain Pass in California, the only US rare earth mine, produces light rare earths. Heavy rare earths used in phone magnets remain almost entirely Chinese. On April 4th, 2025, China issued an announcement. It was not framed as a major escalation. It was framed as a routine update to existing dual-use export licensing rules. 7 specific rare earth elements would now require government licenses to export. Foreign buyers would need to apply through Chinese trade authorities. Approval would be granted on a case-by-case basis. Samarium, gadolinium, terbium, dysprosium, lutetium, scandium, yttrium. 3 of those, terbium, dysprosium, and yttrium, are critical for smartphone components. 3 of those elements are inside the phone in your pocket. Without them, the magnets in the speaker fail at high temperature. Without them, the red phosphors in the display do not produce the right wavelength. By May, European spot prices for some of those elements were running approximately 6 times Chinese prices. Manufacturers outside China who needed to source the same elements were either paying the inflated foreign market price or waiting weeks for Chinese export licenses to be approved on each individual shipment. Western smartphone manufacturers reported difficulty obtaining the magnets they depend on. Some publicly disclosed component shortages in their quarterly filings. Gracelyn Baskarin, who runs the Critical Minerals Security Program at the Center for Strategic and International Studies, summarized it bluntly. We are in an era where executives are willing to pay a significant premium for a reliable supply chain. They do not want stoppage. Some plants reportedly cut production. Inventories drained faster than expected. Replacement orders that had previously been routine now required executive-level escalation to Chinese suppliers. From the consumer's perspective, none of this was visible. Phones still shipped, speakers still played sound, microphones still captured voices. But underneath, component costs rose, supply chains tightened, and the exposure of every smartphone manufacturer to one specific country became operationally visible. Several major manufacturers raised their projected hardware cost forecasts for 2026 by between 1% and 3%. There is no smartphone manufactured today that does not depend on this chain. Every brand on every continent depends on rare earth components flowing through Chinese refineries. Which brings us back to Apple's $500 million deal. It was the world's largest consumer electronics company, finally putting capital behind a domestic alternative. MP Materials CEO James Litinsky called it a structural turning point. Quote, "This collaboration deepens our vertical integration, strengthens supply chain resilience, and reinforces America's industrial capacity at a pivotal moment." But that $500 million is less than 0.5% of 1 year's iPhone revenue. What that ratio tells you is how deep the dependency runs. Building parallel domestic capacity for rare earth processing at the scale needed to supply hundreds of millions of phones is a multi-decade project. The first finished magnets from MP Materials will not ship until 2027. Other projects are in motion. Lynas in Australia, Iluka, new refineries in Texas and Estonia. Most are years away from commercial scale production for the elements that matter most to phones. Most realistic projections do not bring Western share of phone-relevant rare earth processing above 25% before 2030. Approximately 1.2 billion smartphones are shipped each year, each one carrying roughly 0.1 to 0.5 grams of rare earth materials inside. Multiplied across 1.2 billion phones, that is between 120 and 600 metric tons of rare earth material flowing into smartphones every year. Every smartphone shipping in 2026 contains rare earth elements processed in China. Those 60, 90, 99 concentration numbers were essentially the same in 2010, the same in 2025, the same projected for 2026. Slow change at the margins. The picture at the core stays the same. By 2030, optimistic projections suggest 70 to 80% of phone-relevant rare earth processing still flows through China. Slow change at the margins. The picture at the core stays the same. And the phone in your pocket, likely the one you were watching this on, runs on it. Most users will never think about any of this. The phone is opened, used, and put away. Photos are taken. Videos are watched. Music is heard. Voice notes are recorded. All of it functioning normally. All of it dependent on the same supply chain. Knowing the chain exists does not change the chain, but it changes how the next news headline about rare earth restrictions reads. So here is what we have seen. 8 rare earth elements doing 5 different jobs inside every smartphone, and 1 country supplying nearly all of them. 3 magnets in the speaker, microphone, and vibration motor, built around neodymium with dysprosium added to keep them stable when the phone heats up in your pocket. 1 camera lens stack, lanthanum oxide glass elements, bending light through a millimeter to give you a thin phone with sharp images. 1 display layer, yttrium and europium phosphors generating the red on your screen. Cerium oxide polishing the glass you look through. All of it routed through 1 country. China mining roughly 60% of the global supply and refining roughly 90% of what gets used worldwide. And the next time you take a photo, send a voice note, watch a video, or feel the buzz of a notification, you will know what happened underneath. A neodymium magnet pushed air into your speaker. A lanthanum lens focused light onto your sensor. Yttrium phosphors generated the red. Cerium polished the glass. Apple's $500 million deal with MP Materials was the first attempt to break this dependency from inside the smartphone industry. The first finished magnets from MP Materials will not ship until 2027. Lynas is building. Iluka is building. New refineries are under construction in Texas and Estonia. Mountain Pass mines, but does not refine for phones. Heavy rare earths still flow through Chinese facilities. By 2030, optimistic projections suggest 70 to 80% of phone-relevant rare earth processing still flows through China. Until then, every phone in every pocket continues to operate on materials processed almost entirely in 1 country. Knowing the chain exists does not change the chain, but it changes how the next news headline about rare earth restrictions reads. Because every news headline about rare earth supply is a headline about the device in your hand. The phone still works. The chain underneath does not change. 8 rare earth elements working silently inside the device that has become inseparable from modern life. Almost all of them refined, processed, and finished in 1 specific country. 8 elements, 1 country, 1.2 billion phones a year. The phone in your pocket, right now. Apple's deal in California was the world's largest consumer electronics company, finally putting capital behind a domestic alternative. Until that capital becomes finished magnets, the chain holds. The phone in your hand is finished, branded, and assembled in many places. The materials that make it work are not, and the chain, for now, is held in one country's hands.